Okay, in the last lesson, we wrote this action, but actually, we only wrote less than a third of it because it's really too complex. Since you have to write both the upper part and the lower part, this thing is particularly complicated, and each function has its specific purpose. Actually, the main function of this action is to pull up this runnable thing. Writing one more like this doesn't affect anything. After pulling it up, then create it and throw it into the thread pool to let it create and execute. And actually, this is an independent thread. It's not thrown into the pool. It directly creates a thread to execute, and you can also close it at any time on this end. Yeah, because this is for communication. If you want to make a TCP communication plugin yourself, you can refer to this lesson to do it. Because this is really, I personally think this tutorial is much more difficult than the previous. Much more difficult than the previous lesson where we wrote HTTP plus WebSocket. When I recorded it myself, I also found it quite troublesome. Then, in this part, after we have this ExecAction, we can operate on the upper end of LSEC. So actually regarding this operation, let's write out the upper part first. First of all, we definitely need to actually create it. Creating it is very simple. We just need to get our subsystem. It's very straightforward here because we control the lifecycle of this thing ourselves. Therefore, we don't really need to worry about any entanglements it might have with the engine because we know that when the module starts, created it directly. So we can just go ahead and do it like this. Okay. After biting it, we can just directly call its internal method to create it. Of course, we haven't written the methods inside yet. We'll write them in a moment. This method hasn't been written yet. We'll just write it in a moment because this place is just a relay. So obviously this place is the same. We get this subsystem. We go get this method. Let's first lay out the upper level logic for everyone. Okay, then for continuing to check a certain state here, we'll just do it this way. Here we also call this method. However, 来自 s 代词 by 词 p 为 d, there is a b found here. That is to say, this action might have already ended. So there is a by found here. Okay, then for removal, we first get this subsystem. Directly use the removal method within this system. Okay. Alright, then we release it. That is, release all of them, right? And this is for removing a single one. Then we align this here. Okay, there's no such method yet. Then we switch to a subsystem. We'll just write out these methods directly. As for these methods, we'll put them below here. Write them below here. I'll just paste it here. It's quite simple. There should be 5 methods in total, right? Okay, now we need to pay attention to the types here. We need to copy the type over. Should be this info, right? Info information. Then it's consistent. Then we need to use this proxy. Return this proxy. Okay, this enumeration should be this enumeration. Okay, so these are the 5 methods. Okay, let's get these 5 methods done in one go. Okay, after that, we definitely need a container here. So we'll use TMap because we want to. This TMap is something we can use when distributing. It's more convenient. We can directly use GUID to delete it. We're using smart pointers here, and they are thread-safe smart pointers. Obviously, we need to include this one-step action here. Good. After including the one-step action, the error is gone. Then we compile it. First, make sure the compilation is fine. Good. The compilation is fine. Okay. After the compilation is fine, let's take another look here. There's no problem here because this is the user. He only allows us to use these few methods. Then we will start writing this creation one by one. The idea behind this creation is actually very simple because under the subsystem, we added another layer. So we just need to go through this place to call its static method. Then the object it returns is actually a smart pointer. We need to add it in. It is a thread-safe smart pointer. Okay, then after this object, we add it to the container. Then this object of our smart pointer. cannot be brought into the blueprint. We also do not support reflection, so in our blueprint, it does not need to obtain this thing. It only needs to obtain our ID. Based on our ID, to retrieve the relevant information, this actually creates a simple isolation. Okay, adjust the position here. Okay, then here. Actually, this is what we learned earlier with TMap. We just need to get all the k values. Then we return this k value to get all the actions currently being executed or being processed in some way. Next, we will query this state. Since this is a TMap, it's very easy to write. Actually, we can directly query using find to find. Then let me check find, change this part, change the enum here. If we find it, note that this part is a bit special. It points to a pointer of a smart pointer. So we are pointing to a pointer of a smart pointer. When you actually retrieve the state, and then call it using the arrow operator. Note this signal here. We explained this find earlier. This is a very common pointer-to-pointer pattern, a common part because it returns a pointer. And then the pointer pointing to it is a bit confusing. You'll need to sort it out yourself. Once you figure it out once, you'll understand what I mean. If it's not found here, we just assign loan to force. As for this removal, actually we directly call this TMap and then it's done. We directly use the TMap's remove method to remove it. And then if it removes, it should be only 1. If it's greater than 1, it proves the removal was successful. If not, then it doesn't exist at all. And for empty, we just directly modify empty. Okay, when we have this pair, then basically our upper level structure is finished for everyone. This serves as a bridge between layers. Yes, and then after the upper level structure is written, let's take another look. So pay attention here. This object is managed through smart pointer. It is being created. When it is created, it is actually not created through this constructor. It will only be created through this place. This static method creates it here. And when it is destructed, it will go through here. This will definitely release all the thread resources and these things. So this is a detail to pay attention to. Let's take another look, because I'm afraid this part isn't clear. Everyone gets confused when they continue writing below, because it gets even more complicated later, and this part is the activity. Activity is where we actually create the thread, because we let it execute across one frame. Then in the next frame here, we go through the activity and then actually go into this activity internal. And this is where we create our thread. Creating the thread actually means instantiating our runnable. Create a thread and suspend it for use. When closing, we only need to close our runnable. Of course, we haven't written anything in our runnable yet. We'll write it later. And this method almost got missed. That is, we need to notify. That is, notify our subsystem that it needs to perform a removal operation on itself. Why is there such an operational approach here? This is because you have two ways. One is that you are halfway through playing and you want to actively turn it off. Another way is that it has finished executing. Then it will definitely turn off. You don't need to keep it hanging in memory. So this is the approach I have here. So here we go to this method. That is when our thread ends. It will call this method. So let's stop here for now. The timing of its invocation is relatively complicated to explain. So we need to explain it later. When this thing is called, this should be it. First of all, its invocation timing is definitely not in the destructor, because calling it means you want to destroy this object. This object says it has already been destroyed. So why would you definitely not call it here? So you can take notes on this part. Okay. So the invocation timing of this function is quite special. So this stage code actually means it will close at the end. No matter after this task finishes, then it needs to execute. Then this part comes from Apple. And here we need to organize and save this information. It's like when we finally finish, we have this information. Right, so here we have a state message. When this task finally ends, you will have this information. And after this information is done, we can automatically close this runnable. Okay, its call timing is also quite special. Okay. So regarding the call timing, we might have to explain when it is called in the next lesson. You know, this method is called when the task finally ends. It will call this method. Then you just need to actively release the relevant thread resources. Let's continue looking below. These methods need to be bound to our thread. We haven't written the thread yet, so let's ignore them for now. As for this generate method, et call actually also dispatched through our thread. We haven't written the thread yet either, so let's ignore it for now. Let's compile it like this. Okay, there should be no problem. Okay, so these methods are all related to our existing ones. We'll write them in the next lesson. Okay, we'll stop here for this lesson. Thank you, everyone.